So what we are working on to overcome these, Ali, to overcome these, we robots are very good at repetitive tasks. If you ask the therapist to repeatedly do the things, it will get bored. So we do not want to replace the therapist, but instead we do not want to replace the human being, but we want to have a child-friendly character which will help the child to continuously learn and to prepare them for the mainstream education. So that maybe these robots, after having interacted with these robots for 6 months, the child may be able to be admitted into the mainstream school. So ultimately, purpose is not to make dependent on the robot, but to make them independent. So the advantages of robots are that it can't get annoyed with repeated tasks, and it will prepare child for the socialization. And it has been seen that such children has special liking for the technology. They are very good at computers and robots. So it will be a very good mode of this. So there are already existing robots in the market. This is the Q robot and Milo robot and nano robot. For this nano robot costs about 30 lakh rupees. It comes with the various accessories, and it has been, their research has been reported that positive results has been found by using robots for such children. But the cost of this is from 1 to 3 million rupees, and these are not available in Pakistan. So we at our mechatronic engineering department have been trying to develop such robots at low cost, but with the same efficiency, accuracy, and the results. So this is one such project which was funded by the Ignite, prepared by our first batch of student, F16 mechatronic engineering students. So this robot can teach alphabet, colors, and shapes to children interactively. Unfortunately, due to this COVID situation, we are not able to have the trials for this. It contains the usual sensors and microphones that you are already aware with. Next one. So this is the demo that the students prepared, in which they are interacting with the robot. Sound is not audible. There is a sound in which the students are talking with the robot.
I'm searching Wikipedia. The best match I made, according to Wikipedia, is strawberry pie.
So it has a Google API, which you can you can search answers by asking the questions. So this is educational cum therapy robot. Next. So the next challenges we face is that these robots use the English language. So we are working on the similar robot, but with the Urdu and Sindhi capability and more friendly child. Look, one of the group is working to develop a toy type robot. So thank you very much. If you have any question, I am available. It was quite straightforward, so maybe there's no question.
Thank you so much, sir. That was amazing presentation, I must say, because I'm feeling honored to be part of this workshop where I came to know about such subjects. We might want to discuss this later on, and I would love to be part of such project, which is so humanitarian. Sir is a great teacher as well, with this reminds me of Caesar's quote that real education should consist of drawing the goodness and the best out of our own students. What better books can there be than the Book of Humanity? Moving forward, we all feel honored to have with us the Honorable Professor Dr. Bhavani Shankar Chaudhary. So you hardly need an introduction. You have met all of us proud by your distinguished work in numerous capacities. As said by intellectual, give man a fish and you feed him for a day. Teach a man to fish and you feed him for a lifetime. That correctly depicts the kind of teaching, sir, Professor Dr. Bhavani Shankar has been propagating throughout the years. So thank you so much, sir. And I would like to invite you on the stage for a keynote speech.
Thank you very much for nice introduction. My presentation is there. That presentation actually, first of all, very good morning. Assalamu alaikum. So everyone is active and kicking. Just have a clapping for DS Railway who traveled all the way from Karachi. एक और clapping हो जाए. दूसरा ये कि इससे आपको एनर्जी भी मिलेगी सबनी के एकड़ी and good thing coming people who are working in field and when I met one of the predecessor in अॻ में जेको खटक साहब हो रेलवे जा जने इश्यूज डिस्कस पे कया न मुख्य ॿुधायो जने कराची खां पिशावर जने गाड़ी वञे थी न there are 84 variables means those changes they get varied. So depends on the signals, depend on the track को अॻियां अची थो वञे फाटक बंद कोने खुलियल आहे अचानक फाटक क्रॉसिंग थी वई. There are so many variables. ॿी गाड़ी लेट थी वई कुछ बि थी वियो. So हुनखे हिकिड़े स्टेज तां ॿिए स्टेज हुन ताईं स्टेशन ताईं या डेस्टिनेशन ताईं पहुचण में because of so many variables to control those variables, it's all major is the engineering management task. So telling you all those parameters is that there's a huge scope. Whatever anything happens, we hear about accident, we must think why it has happened. It's not only railway, it's academia. Academia in the world comes at the lead. It's only not faculty members, it's the students. I went to England in 1984 to do my PhD. Professor wrote me a topic, though at that time there was no technology. He gave me admission in microprocessor applications. I never heard of microprocessor before going there. There was nothing in syllabus as such microprocessor technology because it is something new came. So I took that, offer letter to one of the teacher. He said, yes, this is new technology, but it's very challenging. If you would like to accept challenge, you may avail. Otherwise, you try to have different subject. I arrived, reached there 2 days. After 2 days, I think secretary arranged meeting with the professor. And he said, tell me what type of knowledge about microprocessor technology you know. So even it was very difficult for me to repeat the word, microprocessor or something like that. I couldn't say proper pronunciation. And that used to happen when I returned back from UK and started teaching, and people don't used to say that word properly because of course it's something new term coined on that. So once you are in environment, you accept the challenge. Then he took us to, he gave me one assignment for a month, and that I completed, I think in 21 days of programming that microchip actually. So books were available, there was no net, nothing, but there are a lot of help there. Some others, colleagues, they also guided. So then he took me a chemical industry. He said he wants to develop a new chemical sensor. Now for that chemical sensor, he said the material I would like to select is the polymer material. I never heard, by God, I never heard about polymer. How could electronic graduate know about the first different materials, then chemistry, and then polymer? And then he said within the polymer there are many, but for sensing, we have to go for polymethyl methacrylate or something. Again, you know, I was just behosh thiyan waro us thori der mein ekdo industry mein hua si. Then he said, in that one, you have to work, we have to design a sensor. They should work at the very low, ultra low frequency. Asanji 50 hertz ACR, 50 cycles per second. He said, you have to work only at 1 hertz, 2 hertz. Your signals, sensor should capture. So you have to find that property. Would you like to accept that challenge? Then I said, you know, with your support and guidance, definitely something in your mind, and it's really good thing they need, because something happens in that process industry, those mines, they need that type of sensor. So I had to develop an instrumentation, intelligent instrumentation for measuring the property of that material actually. Then another guy there, he wanted to put into a sensor, and then third one has to attach with the microprocessor technology. So 3 people working together on same project, but it was, everyone was having gigantic task. So things are that you have got, what I would say, every one of you are a big project. Every student is a project. Every student is a unique. एक मेरा आर्टिकल है उर्दू में, आप जरूर पढ़ें, गूगल करें, आप मुनफरद हैं. God has given us enormous talent, enormous potential. We only underestimate our potential. जो यूरोप, अमेरिका जो चीजें डेवलप उन्होंने की है, वहां जाते हैं, ये वो कोई ऊपर से खलाई मखलूक नहीं है. This is all talent we all have. We underestimate our talent. And if we see some of those innovation in US, Europe, many Pakistanis or Asians, they have done those innovations. So yes, sometimes you need enabling environment. And now universities, they are creating. If you are serious, you can find that in enabling environment every place. Like in this project, everyone said, oh, Pakistan Railway will not cooperate. They don't listen. But when we tried, we got such a wonderful response from everyone. So whenever we were asking, oh, we are going there, they always welcomed us. And so because we wanted to identify some of the problems, we cannot have a solution overnight, but to identify, apply some algorithms. So this was the one of the talk. I don't know, can you see one of the conference, international conference on computing and technological solutions with artificial intelligence, that was held in UK. And they invited me to deliver a talk, keynote talk, person from third world country to deliver a talk in UK on this subject. So I thought to share that talk with you, what I delivered there. I gave the name DRAV. I don't know, have you anyone, Google that? DRAV is development of real autonomous track. I mean, that was the heading, and then I brought the word DRAV. DRAV is the one of the old word of the drive. Because in our work, we are thinking about, I saw that push-up trolley, pushing trolley, and now they have got motorized trolley as well. But that push-up trolley, this is like a pushing something to drive actually. So I gave name DRAV, and that conference people that like that heading. So that is some of the project we are going to discuss, and we got this National Center of Robotics Automation there, and all those support from International Islamic University Malaysia and other collaboration. I'm thankful. I have written one name, Ali Akbar Shah, but we have got team. We got Fizza, we have got Mehran, we have got Pali, those they have worked. I think some students are there. Where this row is why don't you come in the front here? There are good spaces here. So I got these young people, they have worked, our research associates and assistants, they have developed on that algorithm. We go to next slide. I go through that outline quickly. I tell about my humble beginning. It's very important because in international place, every time I put that, my university, then about little bit railway development of this vehicle, some results and some of the significant contribution. So we go to the next slide. I read a book of Malcolm Gladwell. I think if you feel it's opportunity, it's a freeware available, story of success. आप जहां से हैं उस जगह को कभी नहीं भूलें. वो कहता है उसको कभी नहीं भूलें. The place where you belong to. So I tell you the place when we used to have, you know, sometime class, sometime under the tree. I was born in third desert. We used to fetch water from the wells. Ride on the camels or some of those trucks. But now Thar is being changed, you know, because of the coal or black gold. So we go to the next slide. So you see Thar is being transformed now because it has got 175 billion tons of ignite coal, which can produce 100,000 megawatt of electricity for next 100 years, which is sufficient. And you can see the females, they are now driving those heavy trucks and loading trucks. Next one. And you can see almost now it is becoming even tourist place. I usually now call it is the Dubai of Pakistan, that Thar is being transformed. You know, they are not, ladies are not driving, but they are even repairing and maintaining that. And you can see Karunjar mountain there, and they have got huge tree plantation. That was one of the Angro. They arranged one official talk there, and they asked me to be a part of 1 million tree. Next one. And you see almost every head of state I visited. So something you are creating, we have created something, and DS Railway, I believe people from the industry, they usually don't come to the university. You know, you have to develop a trust, you have to contribute. Now people are visiting, every prime minister, every head of state visited, and Thar is having now airport. The next one. And that is one of the 660 megawatt plant energized. Next one. It would be unfair. I think most of you know about Mehran University, but the guest from our chief guest and those people, let me share. Mehran University in one of the last HEC ranking ranked as the 4th best engineering university of the country and 1st engineering university of the province. There has been no ranking since last 4 years, let me admit. Next one. And that is on the right bank of Indus Canal, that everyone knows. So this is for people from abroad, international. Next one. And the university is spread over 2,000 acres land. You know, people are dying for 1 acre, 10 acre. When I visit as a higher education commission member to different universities, their minimum requirement is 10, 12 acres land to start a university. They don't have even 1 acre land. They are opening in plaza or something like that, and usually HEC doesn't give permission. We are lucky that we are blessed, and we are having iconic buildings. So there are huge opportunity to, you know, use those of facilities. Next one. So now we are coming to Pakistan Railway accident. That is the report of Dawn. I think we are tough year for Pakistan Railway 2019. You know, it was full of, I mean, there were 100 accidents. And if you see some of the pointer is there. So this one. Okay. So if you see here, most of those accidents happened because of derailment. This is the data we compiled, whatever available, and we have got people from Pakistan Railway, and they may further guide us. So if we go to the next slide, we can see the, oh, sorry, now I'm going on fast track. We don't, are thinking to have, is it next one? Sorry. Previous one is this one. Left is previous. Okay, now. So let me try next. This is next one. Let's see next one. So this is one. Okay. So we can see railway accident. This is not only Pakistan. If you see this Mark Jeffren 2019. Read this one. This is one of the latest, publications published in one of the international journal, Railway Track Monitoring Using Train Measurements and Experimental Case Study. So they also mentioned majority of train accidents around the world are triggered due to the track failure. And then one of our paper also published in one of the it's a British journal, Annals of Emerging Technology in Computing, UK journal as well. And what we try to take that data and just to see how we can use Kenny edge detector to identify and discrete 2D discrete wavelet transform to identify those problems and how to overcome those problems. Go to the next slide. This is some railway track condition. So I put some places question marks as well, because experts from railway, they may tell more, because we have taken this data from different resources. Railway tracks are prone to corrugate as they bear excessive amount of loading and harsh environment. We are having such a high temperatures and of course some loading conditions. Some of that railway tracks, they had already surpassed their service life, so they may need replacement. So they are likely to deform or break, ultimately causing invaluable loss of. So the problem is the assets and the human life, both we have to save. And this is the source where we got the data. We go to the next one. The solution around the globe, what are the solution there? The solution there, they use railway track conditioning monitoring. And then we compared that conditioning monitoring in Pakistan. We have got some of the track conditioning monitoring. We had several meetings. They have got also ultrasonic and physical and those motorized vehicles. They go and check that one. But again, we thought these are again limited facility when we compared. This is not a public statement, but this is just a research statement. So maybe we think that skilled manpower is less, so we must go for automation. Monitoring equipment is expensive, as we can see the next slide. So that's why there's a need of developing low-cost smart instrumentation. That's what we pitched this in Higher Education Commission when we were awarded project. There you have to justify actually. We move to the next slide. Here we can quickly see the existing measuring equipment, and that equipment actually checks the health status. This is what internationally they have got, but that is based on Excel-based acceleration methodology. But this is like a complete engine or like a portion of train that is of course quite expensive, and it is the resource we have taken. Hurricane Mark 1C, we are also part of that organization. One of our researcher Ali has been invited to attend some of those meetings as well. Then we have got some other methods as well okay. Infrared thermography, that is not that costly, but you find we have got all those equipments in our lab as well, track joint gaps, and then you have got ultrasonic. When we had a discussion with Pakistan Railway, they mentioned they have got some sort of this device as well that finds internal metallic properties as well. We have got also some of that equipment. And then new technique, I visited 2 years back City University as a European fellow for a month, and they have been working on this fiber break testing. That is one of the very latest, because fiber optics, it's one of the advancement in technology, and that is based on principle of refractive index, and London Underground and many places they install that one. The other is image processing, where you use various gradient filters and to identify track damage, and that is the one of the method we have tried to achieve. So this is quickly just tell you about this National Center. What is this National Center of Robotics and Automation? You heard yesterday Dr. Riaz talk, those who were present. So there are 13 centers established in 13 universities. There are some joint lab. Like our lab is one of the joint lab. It is having two parts, human haptics, human robotics, as well as conditioning monitoring. So at MUET, we are doing conditioning monitoring, and NED, they are doing haptics, human robotic surgery, and all those things. There's a lab in Butam, Quetta. There's a lab in Peshawar, lab in UET Taxila, Swarm Robotics. There's a lab on human-centered robotics, UET. I also like this robot maker lab in NUS. Our scope is to do railway infrastructure conditioning monitoring and railway component conditioning monitoring. In addition, we have we have got another KPI as well, motor that comes rolling component monitoring actually. So already we identified some of the problem that we should go for development of low-cost track recording vehicle. So we worked on that one, and that we thought it must be having solar powered to achieve sustainability development goal, which are very important nowadays, one of the 17 goals. So in that NCRA lab, we don't have any facility of fiber brake grating, but we wanted to have similar result to develop low-cost solution. And we have developed prototype, and we have validated some of its parameters, and you will be surprised to see one of the paper, IEEE transaction. I don't know how many of you heard about IEEE. The Wi-Fi today we are using, it's IEEE standard 802.11. This is IEEE, which is developing a standard in Institute of Electrical Electronics Engineers. It is having branches in every country of the world, student branches, professional branches. So we have to work for having that validation as well. So one of the prototype we developed, because initially you develop small prototype, you can't develop a huge vehicle. You have to see your algorithm is working. Always try to develop small thing. As I mentioned yesterday, I don't know how many of you were present. Which game I talked yesterday? Angry Bird. So Angry Bird, the one who developed Angry Bird, he developed once, only 1 or 2 people visited his website and played that game. He developed second, third, fourth, 45th, only again 3,000 people visited when it got 46th version, 50,000 or something, I don't remember. Those people, they played the game. Then he said, oh, I'm only one step to my success. He developed that 47th version of that, and that is the time. Now he's a billionaire. So we must have to have the patience and the persistence to achieve our target, but always start with something small. Identify a small problem, try to go for that solution. So we try to have small this trolley. Let's see how, thanks to the team, I already mentioned the name. They have worked on the size there, 2 meter by 1.5 meter, because this is all matching of that railway gauge with that steel frame, and it has got wooden wheel to test with, because to avoid that power line communication or to avoid any short circuiting. Then we have got those wheel, 3D wheels were manufactured, all with dimension. We design all its conicity level, and all that modeling was done. And then it's all matched with some of the locomotive mechanism, programmed accordingly. And then let's see it's initially battery operated. So you can see it is all app-based control. It has used Python. It's all open access, open programming language. So we go to the next one. So it has used several damage detection algorithms. It's not only running the trolley on there. You have to develop whatever data acquired. Data has got engine vibration as well, wheel vibration as well. So you have to identify how to filter that data. For that one, those algorithms have been used. It's constructed using those 3D accelerometer and node MCU. That node MCU communicates actually ThinkSpeak using Arduino IDE, integrated development environment, and that data taken and then passed on for 3G connectivity to mobile phone. And it has used how real-time data to MATLAB for applying binary classification. I will avoid technical details because you can, every talk on that again needs couple of hours. Recording the track surface fault using Google Map Developer platform. So all that you can see the in block diagram again quickly. We have got TRV controller module, then diagnosis module. You can see those Bluetooth module, Arduino. These are all again, you can say low cost microprocessor. The cost is 500 to 1,000 rupees. Such those single board computer, very powerful for developing small application. Their cost is less than 1,000 rupees. So you can don't buy one shirt or one dress, better develop small application for your home. It's even layman job. Student from architecture, from CRP, from metallurgy can develop application using one of those boards at home for controlling your motor, controlling your door, or having, bell who is outside. You are, identifying that particular person. Tools are available. You just, you may need for processing, you may need your PC or something like that. So again, we go to the, that's rechargeable battery pack is there. And then once it data is using ThinkSpeak on cloud, then you can do a lot of analytics. So with that integration, see, you can actually get your data processed and you can identify exactly those motions and see the problem. So I go to the results actually, and comparing this one, importing real data to MATLAB and applying classification, we compare different methods. This is very important, that image processing algorithm already people have developed. They found the squat, जो खड्डे होते हैं वो नजर आते हैं, turnout frogs, not dip angles, broken rail, corrugation, yes. So different methods, laser, microphone, but this MOAFIS, we gave the name MOAFIS. The IEEE thing I was telling you was this MOAFIS. One of our paper, MOAFIS, on that railway track monitoring published by IEEE, which is generating standard. It takes 2 years to get published. That paper with 9.92 impact factor published in IEEE IoT transaction within 6 months time. So that is one of the big achievement about our results. They have been validated. They have been gone through reviewers. First time reviewers gave 26-page comments, 26-page comments and questions that we had to answer. Second time they gave 3-page. Third review they gave, I think, only 4 lines. And fourth review they said it's all accepted. So it depends. They give the comments how quickly you reply that one. And we have got some international professors with us in that paper. So we gave the even name MOAFIS, that is in Sindhi or Urdu, you can see means, guarding something. So I will exactly read the title at the end. So it can find the squat, turnout frog, dip angle, drainage problems, broken rail, corrugation. So with all results quickly, I will go through that. We have got all that recording of the track faults using Google Map Developer app platform, which is called API in Python. And all that, whatever accelerometer senses, then all processing is done. And then we can find that particular location actually, that particular squad 1, squad 2, where वो खड़ा कहाँ पे exactly उसमें है. Once we identify, then we can go for solution. So some of the results, I quickly again show you this intact railway track. We again run on the intact railway track and some of the damage, physically you see, and we validated different methods. And we have seen for intact, the amplitude value is nearly 0, almost 0 with respect to the frequency. So I don't go to the analysis data, but each algorithm again needs 1.5 hour presentation for that one. And when we found using that algorithm that when amplitude crosses, 0.6 and reaches to around 1, then we found that it has got some of that squat identified. We got a couple of results there. I think in next one. Again, we are grateful to Pakistan Railway for facilitating us for getting the data, because based on that data, we had to validate our system. You can see different data, this is the what industry or the government to have that triple helix or nowadays called 4 helix model, that whatever you are working, you want to achieve sustainable development goal, means serving the society need advice, serving the industry, serving the government. So we are grateful again for the data. And if I see healthy track, we got when we get results in terms of wavelet transform and using our detection algorithm, it's almost 0. And then mild fault, it has got little, in wavelet, because we are applying 2 algorithms to verify those ones. And then moderate fault on that gauge or track, then it is having nearly peak 1. And then we have got full damage track, then you can see the so it's not only one way of validation, 2 ways of validation we have applied. Thanks to again the team. I myself is playing role of the catalyst only. We go to the conclusion. So there is a great need actually for developing some engineering application for our socio-economic development. Whatever is you have been doing, always think what and always think about how you can make your tomorrow better than today. Just keep that in your diary. Tomorrow better than today. So whatever you are today, what new thing you have learned tomorrow. Even I say, if I have taken one plastic की एक बैग शॉपर बार है ना, वो आज मैंने पिक कर ली, देख ली, तो मैंने वो भी एक बड़ा अचीवमेंट कर ली. ये भी एक बड़ी कंट्रीब्यूशन हो जाएगी कि कल जो बैग वहां 10 पड़ी थी खराब गली में, आज वो नहीं होंगी, कोई उधर से गुजरेगा तो कितना अच्छा लगेगा. So we have to think in that way, only then we can achieve those things. We have gone through, we have seen that those commercial track recording vehicles, they are gigantic in size, operation cost is very expensive, they themselves are expensive, and for sudden track faults, they are not feasible. And our wireless sensor network based, it is low cost, fully electrical, autonomous TRV, having 3 years battery life. It's still a lot of work to be done. It's not at the end of the world. It's again prototype. It may need to go through many validation. We are thankful to Pakistan Railway. They have provided us auxiliary track in front of our main library. And we have to again validate before going for commercialization. This is just throwing some actually spotlight that people always underestimate. People, faculty members, you students working here, you have written a books, and those books from Mehran, they have been published by Springer Verlag, Germany. A latest book by 3 faculty members happens, I'm part of that one. IoT architecture models, it's published by library, it is having Library of Congress cataloging by US press and as a premier reference book as well. So some of those books already, those conferences held in Mehran and their books published by them. And now coming to that topic, the paper Amorphis, its complete title is IoT based track recording vehicle for damage analysis in railway track. IEEE Internet Journal of, it was accepted in February, but published in June, I think. So it's Google, you can download, it's available, you can through our library. Otherwise, it's $53, but through Mehran University Library, you can have that free. So thank you very much. I think this is the last slide. So thank you for hearing me patiently. So any question coming, and we have got any comment? Well, of course, we will hear more from our chief guest. We are expecting after this another lecture. Vice Chancellor would be coming here soon, and we'll have more. And there's one lecture remaining coming all the way from Denmark. People from Pakistani who's working in Denmark in Siemens, and he's going to deliver that talk. So I hand over To you.
Thank you so much, sir. Professor Dr. Bhavani Shankar is very generous and humble person, and you're absolutely right. We should never forget our roots because that's something that makes us stronger, right? Moving forward, like Dean William once said, the aim of education is the knowledge not of fact but of values. It is an occasion like this, ladies and gentlemen, where we get opportunities to test our knowledge and understanding regarding different subjects other than our area. In order to fulfill this desire, I would like to call Mr. Hanif Kuldi's Pakistan Railways, who got his LLB education from University of Punjab and then got master's degree from Railway System and Engineering, UK, and also a Spurs Fellow at MIT USA Special Program in Urban and I'm extremely sorry for the inconvenience occurred at a moment. Instead of sir, we are going to call Dr. Ali Ahmed he is the keynote speaker. I would like to introduce him that he is currently working on lightweight collaborative robots for industrial automation at Denmark. Ali Ahmed Malik is working as an expert for robotics and automation at Siemens Renewable Energy. Ali received his PhD and master's from University of Southern Denmark. Mr. Ali is active in the research of human robot teams and digital twins in production systems, and his articles have been published in Science Robotics, Journal of Computer Integrated Manufacturing, CR Panels, World Economic Forum, and other outlets. He got Festo Prize for Young Researchers and Scientists 2017 DAM Symposium on Intelligent Manufacturing. From 2016-17, he worked as research engineer at Industrial Automation Denmark and has gotten a PhD degree this year. Please, sir.
Good morning. Can you hear me? Hello, can you hear me?
Hello. Yes, sir, we can hear you.
Okay, super. Thanks. First of all, I'm very sorry that there was some disruption due to or interruption due to internet and file sharing, file opening. But finally, I got able to get connected. I'm still unable to open my camera. The thing is that I am in Pakistan for this week and I am having some problems with the internet, and the Zoom link that I received, it was not working for me. However, I can present my work to a large degree, and also I can present an introduction to myself. And I hope you can see my screen as well. Okay, so my name is Ali Ahmed Malik, and as you have already been introduced to me in the introduction, that I'm working as an expert for robotics and automation in Siemens Gamesa Renewable Energy. We are among the world's top wind turbines manufacturers, and we have manufacturing facilities in Denmark, Germany, Spain, USA, India, Egypt, and we are producing almost the largest wind turbines, offshore wind turbines in the world, up to 14 and 15 megawatt. And I am working as an expert for robotics and automation in the company. We are a group of that is called Strategy and Corporate Affairs. And our group or our department works on future technologies. My little introduction is that I have done PhD in manufacturing systems, more specifically in human robot teams for manufacturing systems. I did MSc engineering. Also in MSc, I worked on my thesis with a manufacturing company in Denmark, and my master thesis was also about future factories. So future factories is something that has always excited me. And this is why I have always worked in this domain of manufacturing of the future, or factories of the future. I did BSc in industrial engineering from Punjab University, Lahore. From work experience, I have worked presently I'm working with Siemens Renewable Energy. In the past, for a brief period of time, I have remained assistant professor at University of Southern Denmark in Denmark. Also, I worked at Linek. It is also a manufacturing company in Denmark that manufactures electronic linear actuators. I worked at Denfos as a research engineer and also at SNGPL. Okay, so this is a little bit introduction to myself. A brief introduction to my organization or my company. After that, I will come to our work in relation to collaborative robots or human robot teams in manufacturing systems. As I have already told that we are, the Siemens Gamesa is a global leading provider of wind turbine products. We operate as an independent company, but we have like shares. It is something you don't need to understand in detail, but it is something that we are, each Siemens company is partially owned by Siemens AG, and then there are shares by some other companies. So it is something not to dig deep. We are almost 26,000 employees, and we have a portfolio covering all requirements. I mean, we are producing offshore wind turbines, we are producing onshore wind turbines, and we also offer services. Total capacity that we have installed up to now is 107 gigawatts. And besides this, as I have already told, कि हमारी जो production facilities हैं, I hope कि उर्दू में बात करने में कोई problem नहीं होगी. तो हमारी जो production facilities हैं वो हैम्बर्ग में है, स्पेन में है, बिल्बाओ, डेनमार्क में 3 production facilities हैं, इसी तरह इंडिया में, USA में, इजिप्ट में. ये जो आप नसल एंड ब्लेड्स देख रहे हैं, इससे क्या मुराद है कि नसल इज ब्लेड इज द कंपोनेंट like the blades of the wind turbine, and then there is nacelle is the back component of wind turbine. तो हम ये नसल और ब्लेड्स, ये दोनों चीज़ें मुख्तलिफ फैक्ट्रीज में प्रोड्यूस होती हैं. यहाँ पे एक वीडियो है जो कि वो फाइल शेयरिंग में प्रॉब्लम था. मैं वीडियोस जो हैं इस वक्त मैं PDF फाइल से प्रेजेंट कर रहा हूँ, तो मैं कुछ वीडियोस जो हैं वो YouTube से डायरेक्टली प्ले करने की कोशिश करूँगा. Okay, this was just an introduction or corporate video to the company. And if you want to know more about our company and our products and our services, you can log on to social media websites and you can find a lot of information about us. Okay, coming to the topic of collaborative robots and automation. As I have already told you that we are a group that is called Strategy and Corporate Affairs. So in the Strategy and Corporate Affairs, we are working to develop future technologies, not only for our products, I mean, not only the wind turbine technologies for wind turbines, but also how to make those future wind turbines. There are a lot of technologies that we are working with, for example, new materials, new ways of recycling the blades, ways of manufacturing those components, and also new technologies to integrate in our future manufacturing systems. And one of the technology that we are very excited about is robotics. Robotics is not something new. I mean, in factories, robotics are well known. And if you go to a manufacturing plant, more specifically an automotive manufacturing plant, you will see hundreds of robots in a single plant. So in factories, robotics is not something new. However, and in the next slide, you can see that there are almost 2.7 million industrial robot installations there are worldwide, and it becomes almost 113 robot units per 10,000 employees worldwide. This robot penetration is different in different countries, depending on different reasons. One of the reason is the high cost of workforce, which is in some countries is quite high, and this is one motivation to have more robots, but there are other reasons as well. However, having all this industrial automation or robot automation, we still see that there are a lot of activities in manufacturing plants that are manual. More specifically, assembly is an activity that is highly manual, and असेंबली आप समझते होंगे ना, असेंबली जैसे एक प्रोडक्ट होती है, उसके बहुत से कंपोनेंट्स होते हैं, उनको जब आप मिलाते हैं, एक दूसरे में ज्वाइन करते हैं, तो ये असेंबलिंग हम जब करते हैं, तो असेंबलिंग एक ऐसी एक्टिविटी है जो हाईली मैनुअल है अक्सर कंपनीज में. इवन इन स्मार्टफोन मैन्युफैक्चरिंग 90% ऑफ द एक्टिविटीज आर मैनुअल, एंड दिस more or less similar goes to many other sectors. Also in wind turbines manufacturing, a lot of activities are manual. Actually, it is highly manual production in relation to wind turbines manufacturing. The problem is that 1/3 of the manufacturing employees goes to assembly activities, and 25 to 30% cost of the total manufacturing cost of companies also goes to assembly activities. The problem is that in manufacturing, we see highly manual systems, which is one extreme, and then there is another extreme that we call highly automated systems. But as we move from manual to automated systems, we lose flexibility. We become more productive, but we lose flexibility. There is a new trend that what if we combine the human capabilities and machine capabilities and design new kind of manufacturing systems in the middle area between the manual and automated system. 10 years ago, it was not possible, or maybe 15 years ago, it was not really possible. But now with new technologies that we call collaborative robots, it is becoming more and more possible. And these robots that we refer them as collaborative robots. हम इनको क्यों collaborative robot कहते हैं? कि ये कोलैबोरेट कर सकते हैं ह्यूमंस के साथ. इनका जो कोलैबोरेट की खसूसियत है वो ह्यूमंस से रिलेटेड है, और ह्यूमन जो है वो ये उसके लिए सेफ हैं. जो नॉर्मल रोबोट्स होते हैं, कन्वेंशनल रोबोट्स, इंडस्ट्रियल रोबोट्स, उसमें हमें केजिंग की ज़रूरत होती है या फेंसिंग की ज़रूरत होती है, जबकि जो न्यू रोबोट्स हैं इसमें हमें कोई फेंसिंग नहीं चाहिए, कोई केजिंग नहीं चाहिए. दे आर movable, often they are movable, they are easy to integrate or commission, they are easier to reconfigure, and they are easier to operate. So for these reasons, they are becoming more and more popular. Also at our company, we are getting excited about them, and we are exploring that how this technology can help us to automate at least some of our activities. I'm skipping this. Here I am showing a use case that how, this is not from our company, this is another case from Linux company. And there I had worked to automate one of their assembly cell. I have to skip this slide. Basically, there are two workstations, and two operators are manually assembling the product, which is a battery pack. This battery pack is used with linear actuators in hospital beds to power the linear actuator, electronic linear actuator. And the company wanted to replace at least one operator with a robot and instead of having two stations, the whole task, if the whole task can be performed at one station. So how I did it is that I decomposed the whole product into its components. And then with all the components, we evaluated that which are the tasks that a robot can perform and which are the tasks that a human can better perform. There are different strategies to make these evaluations for robotic performance of tasks. In general, we try to assign those tasks to robots that are repetitive, that don't require a high degree of ergonomic skills, and often if there is some weight lifting activity, then it becomes a suitable task for robots. After having this overview, I had developed a design that how we can place the robot and human working side by side with each other. And once everything was modeled in a computer software, then I had used simulations to make further evaluations. And in that evaluations, we can define our human operator, her human body measurements, uh, and after having this, it is also important for factory environments to have very accurate cycle time estimates. And if we are not using a simulation software, then it becomes difficult to make cycle time estimates. And cycle time estimates up to second level or a fraction of second, it is very important to have an overview of that how much production would be there in a day or in an hour, and if we can meet takt time requirements or not. I hope you understand takt time and cycle time and these things. I don't have videos for now for them. I will have a video later in this section. There I will show you how we made these estimates. And in the simulation, the robot controller, the actual robot controller of this UR10 robot, UR5 robot is integrated. And therefore, we are able to make correct estimates of the cycle time for each robotic task from the simulation. And then we have also used simulation for make safety assessments, collision assessments, human activities analysis, that how much the operator needs to bend her body to perform a task, etc. And after making all these evaluations, I had developed the real tool according to those designs that were developed virtually, and the grippers, the tools, everything. And finally, the whole cell was, or the production cell was developed. And I hope I have a short video that I can show you. Yes, here in the simulation, you can see that they are performing the task together, the human and the robot, and we could make all, or at least most of the analysis in relation to safety and production in the simulation environment, and also in relation to the placement of the components and the placement of the robot in relation to the reach ability of the robot. Yeah, and once everything was evaluated in the simulation, then the real cell was developed. And here you can see, here it is me. I did this project during my PhD more than a year ago. And here another thing that you can see is that this physical robot is connected with this digital or virtual robot in the simulation. So basically, the simulation is driving the physical robot and they are performing the same task. And this way you can avoid or at least minimize the activities required to program the robot. And now you can see all the weightlifting tasks are being performed by the robot while the operator, which is me actually, is performing all those tasks where some more precise capabilities that are unique characteristics of humans are needed, are being performed, while the robot is performing this screw driving and weightlifting and these kind of activities. Another interesting thing of using simulation is that you can evaluate the whole cell in the VR environment as well. And the operator can be trained in the VR or virtual reality environment. So the operator can wear the headset on her or his head, and then they can enter the environment like in a factory, and they can play with the robot. They can pick the components from different locations, and you can transfer these robot locations to the simulation as well. And if you can transfer this to simulation, then you can transfer it to the real robot as well. So you can kind of do the programming directly from the VR environment, and you can make these layout plannings in the VR environment. So this is one other advantage of using VR. Okay, so this is one case of using a collaborative robot. There is one other case from Siemens where when we developed this component of nacelle, in nacelle we have this component that is called bed frame. In bed frame, we assemble small components that are called magnet mountings. For assembly of magnet mountings, we needed, असल में मैग्नेट माउंटिंग जो है वो स्मॉल कंपोनेंट है जो इस कर्वी सरफेस में कई जगहों पर लगने होते हैं, कई जगहों पर असेंबल होने होते हैं. जब ऑपरेटर इसकी मेजरमेंट करता है हर एक कंपोनेंट की, तो उसको बहुत सा टाइम लगता है कि मैं ये कंपोनेंट कहाँ कहाँ मैंने प्लेस करना है. और जब मैनुअल असेंबलिंग वो करते हैं तो उनको बहुत सा टाइम लग जाता है और उसमें एरर भी काफ़ी ज़्यादा आता है. इस प्रॉब्लम को सॉल्व करने के लिए हम एक रोबोट यूज़ कर रहे हैं, और ये रोबोट क्या करता है कि इसके अंदर तमाम जो राइट लोकेशंस हैं वो सेव हुई हैं, एंड विद लेजर पॉइंटर और लेजर बीम इट पॉइंट्स टू द राइट लोकेशन एंड द ओरिएंटेशन जिसमें ऑपरेटर जो है वो कंपोनेंट को प्लेस करेगा या असेंबल करेगा. तो उसका जो सारा टाइम है मैनुअल मेजरमेंट्स करने का वो बच जाता है, एंड दैट इज अ सिग्निफिकेंट टाइम. और उसके साथ जो एक्यूरेसी का लेवल है वो भी बढ़ जाता है. तो ये दो एडवांटेज हैं जो हमें इस रोबोट को इस्तेमाल करने से हासिल हो रहे हैं. इसकी भी एक शॉर्ट वीडियो मैं शायद दिखा सकता हूँ आपको यहाँ पर. तो ये केबल ट्रेस हैं, जो केबल ट्रेस या मैग्नेट माउंटिंग, देयर आर डिफरेंट कंपोनेंट्स दैट आर assembled on this bed frame, both on the inside and outside. And here you can see that these operators, this is a simulation, but here you can see that this robot has laser beams, and with laser beams, it is a portable robot, and with laser beam, it can point to the assembly locations. And here, I hope you can understand that it is a large component. And another thing is that there is a tendency in wind sector to make large and large wind turbines. So the size of the wind turbines is continuously growing. Now the market largest size is 15 megawatt, and companies are trying to go even higher. So the sizes of the components are growing. and it is becoming difficult to assemble those small components on these curvy surfaces. And in that case, for example, this technology is helping us to at least solve some of the challenges. And here it is a real video from an experiment. It is still under development, this solution. So there are some challenges that we are trying to solve. But we have already filed a patent for that. And also to enable an easier communication between the workers and the robots. So ताकि वर्कर, क्योंकि अगर वर्कर जो है उसको प्रॉब्लम आएगी और रोबोट से इंटीरेक्ट करने में, या वो उसको इतना फ्रेंडली नहीं होगा, हमें हर दफ़ा किसी एक्सपर्ट की या इंजीनियर की ज़रूरत पड़ेगी रोबोट को प्रोग्राम करने के लिए या कोई भी उससे इंटरेक्शन के लिए, तो ये बड़ी प्रॉब्लमेटिक सिचुएशन बन जाएगी. तो इसलिए मैंने ये एक सोल्यूशन डेवलप किया कि ऑपरेटर जो है वो अपनी वॉच के ज़रिए ही कमांड सेंड कर सके रोबोट को. इसी तरह हम इसको स्मार्टफोन से भी कनेक्ट कर सकते हैं या और भी इजी टू इंटरेक्ट सॉल्यूशंस डेवलप कर सकते हैं. अच्छा, ये सेकंड यूज केस है. ये थर्ड यूज केस एक और है जिसमें हम एक रोबोट इस्तेमाल कर रहे हैं, इसी तरह एक कोलैबोरेटिव रोबोट जो कि कुछ प्री असेंबलिंग कर रहा है, कुछ टास्क नट्स एंड बोल्ट्स को असेंबल करता है. इसकी वीडियो इस वक्त मेरे पास नहीं है. लास्टली जस्ट मैं क्विकली डिस्कस करूंगा एक केस जिसमें लास्ट ईयर मैंने काम किया था टुगेदर विद द यूनिवर्सिटी ऑफ कैम्ब्रिज, and we had worked on that how collaborative robots can be used, or human robot teams can be used to solve the challenges of ventilator production. And in that regard, we had made basically this work was mostly done in simulations, but we had argued that the repurposing of factories can be done if we use collaborative robots or human robot teams. The technologies that can help to enable human robot that can help to develop human robot teams are digital twins, modularization, and reconfigurability. So, and this article was published by Science Robotics, which is a sister journal of Science. Okay, so yes, this is all from my side. One last thing that I would like to say is just to wrap up the things. कि हम ये सब क्यों कर रहे हैं? हो सकता है कुछ आप में से ऐसे स्टूडेंट्स हों. I can see that there are many experts in robotics, but maybe for some students it might not be very clear. लेकिन जो last message है वो ये है कि जिस तरह जो नई प्रोडक्ट्स बनती हैं या नई से नई इनोवेशंस होती रहती हैं किसी भी प्रोडक्ट में, या नई प्रोडक्ट्स आती रहती हैं, तो हमें फ्लेक्सिबल मैन्युफैक्चरिंग सिस्टम्स चाहिए होते हैं. एक ऐसे सिस्टम्स जिनमें फ्लेक्सिबिलिटी मौजूद हो कि वो नई प्रोडक्ट्स को या नए डिज़ाइंस को इनकॉर्पोरेट कर सकें या उस तरह की प्रोडक्ट्स को डेवलप कर सकें. तो इसी तरह विंड इंडस्ट्री जो है ये एक ऐसी इंडस्ट्री है जिसमें बहुत तेज़ी से तरक्की हो रही है. तो उसमें आए दिन नई से नई इनोवेशंस होती हैं. अगर हमारे पास फ्लेक्सिबल ऑटोमेशन नहीं होगी, और ह्यूमंस बहुत फ्लेक्सिबल होते हैं, लेकिन ह्यूमंस जो हैं वो उसमें फिर प्रोडक्टिविटी के कुछ इश्यूज आ जाते हैं। तो ऑटोमेशन कुछ किसी डिग्री पे करनी होती है, और उस ऑटोमेशन के लिए हमें ऐसी टेक्नोलॉजीज चाहिए, नई टेक्नोलॉजीज के जो फ्लेक्सिबल ऑटोमेशन एनेबल कर सकें। और ये जो ह्यूमन रोबोट टीम्स है, ये एक ऐसा कॉन्सेप्ट है, ये एक ऐसा आइडिया है कि जो फ्लेक्सिबल ऑटोमेशन को एनेबल कर सकता है, और ये एक ऐसी चीज़ है कि जो हम इस अपनी कंपनी में इम्प्लीमेंट करने की कोशिश कर रहे हैं। थैंक यू वेरी मच। अगर आपको कोई क्वेश्चन हो तो फील फ्री टू आस्क मी।
Thank you so much, Mr. Ali. That was quite informative. And I think along with me, there will be so many students who would like to look into your company. Apart from that, do we have any questions, girls and boys? I would like to welcome our Vice Chancellor. He's a very humble person. And, on this occasion, I would like to say that this gentleman right here is the source of the word My University, because he is the person who brought this, kind of concept into among us. Because before this, we all used to say, this is our university, we study here, but कोई भी एक जो sense of ownership नहीं होता था. But after Vice Chancellor, after bringing up this My University concept, now we all are owning this university, that this is my university. So thank you so much, sir.
Thank you. Dr. Ali Ahmad, just as a token of appreciation, I don't know whether you could see small shield, which will definitely pass on to you. It's a really great contribution, and I think our students and the researchers who attended this talk will definitely get benefit, and they will definitely get in touch. And you are also part of our NCRA international team. So once again, we are grateful. Thank you.
Thank you, Dr. Bhavani, for inviting me. I hope we will have more collaborations and more possibilities for joint research in the future. Thanks again.
Do we have any questions, girls and boys? We don't? Shall we move forward? We do? All right. Please hand over the mic to sir.
Dr. Ali Ahmad, it was a very nice presentation. And I have just two quick questions. The first is that when you develop a collaborative robot, how do you decide that which part is to be performed by the human and which one to be by the robot? And the other related question is that do you leave your system to just find out itself that which task will be best performed by a robot?
Okay, yes, that is an interesting and important question. Thank you for asking me this. One thing is that we can do it by following some structured methods. When I was working in my previous company, because I had an industrial PhD, and during the whole tenure of PhD, I was working with a manufacturing company, and in that manufacturing company we had a lot of robots, and our method for deciding this thing was by experience and by gut feeling. So the experienced technicians and engineers, they were deciding it by just looking at the component and the task, and then they were telling that yeah, a robot can do it or not. Later we developed a method for doing it, a structured method, and that is published in the Journal of Industrial Robot. And in that method, we are decomposing each task into different elements. For example, the component characteristics of the component, characteristics of the task, and safety related elements, and then assigning a score to each of the element. And then if it passes a certain threshold, then we say that, okay, this task is automatable. But yeah, in the future, it should be more an automated activity. So even if the robot can see, if the different components are placed in front of the robot, and the robot just can see the components and then can decide that, okay, this comes task 1, 2, 7, and 11 are the tasks that I can perform, and then tell to the human that, okay, these are the tasks that you have to do because you are better at doing these tasks. So this is something that we would like to do in the future, but at the moment we are doing it by following an Excel sheet experience, but also transferring this Excel sheet to a kind of app to make it more quick. So I hope I answered your question.
Yes, Dr. Alima, thanks for your answer. I forgot to introduce myself. I am Dr. Javed Daudpoto, professor in Department of Mechatronic Engineering. I would love to speak to you and get in touch with you later. And thanks for your talk.
Thanks again. I would really like to get in contact with you.
Thank you so much, Mr. Ali, for taking time out of your busy schedule and being part of this workshop. And thank you so much, Sir Javed, for asking these questions. These might have answered so many unasked questions. Quickly, we'll be moving forward. I would like to call Engineer Amin Mohammed Daudpoto, Project Director, Karachi Circular Railway, to kindly come up to the stage and share the new project with us. Thank you so much, gentlemen.
Mir Majlis, Divisional Superintendent Pakistan Railways, Hanif Gul Sahab, Worthy Vice Chancellor, Dr. Mohammad Aslam Uqaili Sahab, Professor Dr. Shankar Sahab, Dr. Daudpota, and my colleagues, my teachers, and the students. Assalamu alaikum. It's a great pleasure to be here with the academia because we from the Pakistan Railways are having two functions. We are the government, we are the industry. So it's a necessary part to interact with the academia, being a part of the industry of the railways, being a part of the government. Why I say we are the government, we are the industry, because here in Pakistan, railway has not so developed in the private sector to get a status of the industry. Here we function as a professional and as a manager. I being a basically civil engineer from the NED University, along with the Dr. Aslam Uqaili, passed in 86 from NED and got masters in transportation engineering and did my project management from Pakistan Institute of Management and interacted a lot of with the academia in different capacities throughout the country. Presently, I am having a function of the manager as well as a professional, managing a big national project of the Pakistan Railways, Karachi Circular Railway. It's a big demand of the Karachites and the province of the Sindh. It has not a metro transportation. You know better than me, the mega city, that is the metropolitan of Karachi, having a lot of transportation issues. There is no public transport in Karachi. So we are trying to build develop a good project like Orange Line in Lahore that could cater for the transportation issues of the Karachi and the province of Sindh. So here I must congratulate the managers of this event to have an interactive between industry, government, and the academia. And I think it should very routine sessions. We must interact between academia and the industry and the government managers. And it's a congratulation for this university to have a device. They have devised a modest, like Bhavani Shankar taught us that you must start being a student of very little research. So in the track engineering, you have designed a device of the recording the track defects. Being a civil engineer and the track engineer, track practitioner, it's a modest effort by the academia, and it will enhance, it will optimize to a bigger achievements and to understand the things, how we can solve our own problems. So let us have a look on the technical side from the track engineering. Track engineering has got a very excellence in the world. And there are many types of the track infrastructure. I must say track infrastructure. It is not only the track components which constitute the track, but it's a track infrastructure. It comprises track embankment. It comprises the bridges, hydraulic structures under the and over the track. So it's a complete package of the track infrastructure having many components. As far as we see the track from the naked eye, all the things are very clear about the things, how track is being looked by you. It's a straight, it's a cross level, it's a defects in the horizontal and vertical movements. So these are the naked eye as a layman defects you can see from the naked eye. So here we are not in a stage of having a mechanized maintenance. We are trying to shift our mode of working from manual to mechanization. As you see, you have seen the wooden track. If you have seen the wooden track, it is being done by our labor, simple labor, illiterate labor. We call them gang workers, gangmen. And he is accompanied by, the gang is comprising more than 5 persons. And the gang is managed by a gang mate. We call them gang mate. He is supervising the gang work. And the third person, who is the most important in railways, who is the called key man. He is carrying a bag and watching the his beat of more than 4 kilometers a day long, right from starting from sunset, sunrise to sunset. So he is an important person on the track. If you think that track is not like a highway in the road structure, you cannot see a person on the road. When you are driving from right from Karachi to Peshawar, you will never see the labor over there. If my DS manages a train, you say Shalimar Express, you say Karakoram, right from Karachi to Lahore, 25,000 persons at a time watch it to manage to get it from Karachi to Lahore. So it's not an easy scene that you are looking at the highways. It is not like the highway. It's a laborious and mental and physical work required by the railway engineering. So these are the things, parameters, visible parameters one can watch from the naked eye, and you are trying to make it to be measured through a device which is precise, more accurate, and very quick, efficient. So I congratulate all the team who are working on this equipment. Being a trade practitioner, I will be a welcome for the part of this team. And if you invite me, if you ask me, if you require me, I would be the person. It will be my great pleasure to be here. And the event, such events, interactive events with the industry and the government officials who are managing such projects will be welcoming. And all of you, including the academia, if you come to my jurisdiction, I mean, if you have find a time to see the project we are going to execute on Karachi Circuit Railway, we are in a stage of technical feasibility and the financial viability. We have acquired and hired the consultant, and we are paying them. And we are the team with me who are supervising the work of their feasibility studies and the financial models we are going. And this government is endeavoring to bring such a commercial and financial model which is acceptable to the government and the industry and the private sector. That is public-private partnership. And I think our worthy Chancellor knows how the schemes are going to be working on the public-private partnership. And this will be the good example of establishing a good project on the public-private partnership. In this project, the government sector have no money to spend on it, but we will request, we will bring the investors from the private sector to come, design, develop, finance, operate, and maintain this project with the investment, and they will be called concessionaires, and we will request them and we will dedicate them the rights of the commercial, having a commercial rights with them for 20 years, 25 years, like a toll plaza. They will invest the money in the project and they will get the benefits for the coming 20, 30 years. And on this model we are working, and we will showcase this within a month. So, and I would like to invite the Vice Chancellor and the team and the students. Are you all belong to the civil discipline or other disciplines? Oh, different disciplines here. Okay. So this is a composite group of the segment of students having different students. Good. And so they would be welcoming. I will be a great pleasure for me to invite all of you to learn the technical side of the project and the business models and financial models we are going to prepare, and you may try to have a thesis on that. Actually, nowadays, I am in a big need of the institutions like our institute, like they are getting the NMC, National Management Courses, Senior Management Courses, MCMC from the civil servant side. So you are welcome whenever you find a time. You come to us and we will serve you with the data, with the information, and any other thing. Thank you very much.
Thank you so much, Engineer Amir Mohammed Daud Porto, for sharing your project details with us. For those of you who have joined now, I would quickly introduce myself. I'm Falakna Sumro, Assistant Manager, IEEEP, and I would like to welcome Professor Faisal Karim Sheikh. Thank you so for coming. Okay, so now I would request Chief Case to deliver the presidential address, Mr. Hanif Gul. He got his LLB degree from University of Punjab and then master's degree Railway System Engineering from UK, first fellow of MIT USA, Special Program in Urban and Regional Studies. Mr. Hanif Gul belongs to Commercial and Traffic Group of Pakistan Railways and has from 28th Common of the Civil Service. Mr. Hanif Gul has a vast experience of serving in top management positions in Pakistan Railways. Prior to taking the ranks of Divisional Superintendent in Karachi Division, he has discharged his duties as Divisional Superintendent of 3 other divisions of Pakistan Railways, Quetta, Peshawar, and Gwadar, as well as Chief Commercial Manager Headquarters. Sir, kindly come on the stage and give us a little introduction about the working of Pakistan Railways, as well as the collaboration between the Railway and Mehran University. Thank you.
Bismillahirrahmanirrahim. Professor Dr. Muhammad Aslam Uqaili Saab, learned Vice Chancellor, Professor Dr. Bhavani Shankar, Dr. Tanveer Hussain, and other learned members of the faculty, student body, and my senior colleague, Amir Daud Pota Saab. A very good afternoon to all of you. Let me take this opportunity to congratulate the university for arranging this event. It is indeed the time to collaborate between the industry and academia to lead in chalking out the future of Pakistan. When we talk about the future of Pakistan, transportation and transit facilitation lies at its root. If we talk about the geography of Pakistan, its unique placement between the two great countries. We have India on one side, China on the other side, the most populous countries with a very bright future in 21st century, the emerging economic giants. And then we have landlocked Central Asia and Russian economy on its fringes. And we have Iran and Turkey having long-term historical relationship with our region. So when we talk in the context of regional connectivity, the future of Pakistan lies in transit facilitation. And it is not new thought. This thought has been presented by the Chinese to the Pakistanis, and Dr. Javed Berki has documented it that during his 1993 visit, the Chinese president actually talked about the prospects of Pakistan as a transit facilitator and tasked him to work on it. When I went for my MSc to UK, and on my return, there was a workshop organized by Chartered Institute of Logistics and Transport in 2008. It was hosted by Pakistan Railways in Lahore, and I presented a paper there, which was published in their journal also, The Future of Pakistan as a Transit Facilitator. This CPEC is an offshoot of all those thinking, China-Pakistan Economic Corridor, and it is just one component of transit facilitations. Recently, we have a Russian delegation. We received it in Karachi, and we have shown them all our facilities and infrastructure. And they are also interested in establishing a land route with Pakistan through railways. And then we had delegation from Uzbekistan and Azerbaijan. They want to use our ports for their imports, which according to various studies are more economical to them. So we have this vast opportunity of transit facilitation. So when you look at it academically, to facilitate such a huge volume of traffic in bulk over a long distance, the railway industry is key. If you look at the continental development of the United States of America, if you look at the development of Russia, if you look at the development of Europe as a continent, you will see that the development of railways and industrial revolution, they were in synchronization. So if we want to develop as an advanced economy, we need to have a state-of-the-art transport infrastructure. We cannot move forward without it. And you know, like, why this is important? Because we have to learn from the experience of all those economies which developed in the post-World War II era. So take the example of Japan and look at their rail infrastructure. You will see how rail infrastructure play the role in developing the advanced economies. You look at the example of South Korea and look at their rail infrastructure. Again, you will find the similar patterns. You look at the rail infrastructure of China and the post-1978 scenario, and especially after the turn of the millennium in 2001 and 2002, you will again see a pattern that the Chinese government heavily investing in their rail infrastructure and thus transforming their entire set of economies. America was a little late because in post-World War II scenario, they did not realize the importance of rail sector, and their railway infrastructure is comparatively old and dilapidated if we compare it with China, Europe, or other advanced countries. So that thing was got noticed, and during Obama era, they commissioned a study to the Massachusetts Institute of Technology, and Joseph Sussman, the author of Intelligent Transportation System and an advisor to Obama on high-speed trains. He basically steered all those discussions, and he advised the American governments to invest in rail infrastructure if they want to be competitive in 21st century. So the America is also planning to invest heavily and improve their rail transportation infrastructure. Look at the neighboring India. When we were planning CPEC, the original volume of CPEC was $46 billion US. All of us know it. Now, later, some other projects were included, and its volume rose up to 60 to 65 billion. And then we have some future projects. If we take them into account, it is 100 to 110 billion. So in 2015, when I looked at the figures of the development of the Indian railways from their indigenous sources, they were planning to invest $42 billion US in the development of rail infrastructure, which is equivalent to the size of investment of the entire CPEC at that time. So why I'm sharing these information with you, because you should realize that how much important is this industry, and this industry requires multiplicity of skills and multiplicity of specialization. When you develop the railway infrastructure, you need people in mechanical engineering, you need people in mechatronics, you need people in robotics, you need people in artificial intelligence. Because most of you are familiar with Pakistan Railways, so you don't understand that these cutting edge technologies are relevant. But when I visited the system of Denmark in 2007, I traveled in a driverless train. There was no crew on train. It was managed through algorithm and computers way back in 2007. And now, like, the train systems all over the world, they are automatic, they are intelligent, the infrastructure communicate between each other. That's why the safety profile of railway system is very high. When you look at the safety of road infrastructure, rail infrastructure, and aviation infrastructure, the aviation is the safest. If you travel 9.2 billion kilometers by aviation, there is a possibility of one passenger death. If you travel 2.1 billion kilometers by road, there is a possibility of one passenger death. If you travel on the railways, conventional railways, the possibility of a passenger death is between 4 to 5 billion kilometers. But if you travel on high-speed train, which has been developed by Japan, China, and it's functional in France as TGV and Spain, the one passenger casualty is after 8.7 billion kilometers. So a high-speed train and aviation industries, they are almost at par in terms of safety. And high-speed train is 10 times more fuel efficient and economic friendly than than the aviation industries. And all these studies have been documented. They are proper studies which have been conducted by the proper researchers comprising of experts from academia and practical industries. So when we link the prospects of these industries to economic development, there was a study commissioned by the United States government, and the report is available on Google, not the entire version, but abridged version, Lord Huntington report. You should go through and study that report. And he has established by studies of different metropolitans in the world that cities with efficient railway transportation infrastructure have a clear advantage of GDP over other countries lacking such infrastructure. And they came up with a figure that on average, cities with good and efficient transportation system grows at a rate of 1.5 to 2% more. So for example, if the GDP growth rate of Karachi is 4%, and it does not have an efficient and reliable transportation system, the average growth of rate of New Delhi, which has an efficient rail transportation system, will be 6%. So this 2% difference in GDP growth is huge. And over the years, it creates a lot of difference between the countries and the economies. So as a future of Pakistan, as a future planner of Pakistan, and as an architect of the future of Pakistan, you must keep these facts in mind, that if we want a prosperous Pakistan, that will not happen in vacuum. If we want to have a country of our dream, a country which will go into G20 and then G10 and G8, and which will become a force to reckon with, we will have to visualize it first in our mind, that this is the kind of country that we want to create. And for creating that kind of country, we will have to become the kind of individual that we want to become. It is the individual, the quality of individual, the excellence of individual that creates such kind of countries and economies. It is not by chance that Karl Marx was born in Germany. It is not by chance that Hegel was born in Germany. It is not by chance that Freud was born in Germany. It is not by chance that Einstein was born in Germany. It is the tradition of excellence that carry forward the tradition of excellence. If you create the tradition of mediocrity in a country, the tradition of mediocrity is carried forward. So my request to you from this platform is that the academia has created this vibrant environment. They have established linkages at the international forum with leading researchers and scientists. You should take advantage of that opportunity. You should collaborate with them. And you should consider yourself as a budding Einstein, as a budding Isaac Newton, as someone capable of winning Nobel Prize, because it is people like you who can create difference. When I was in MIT, I was mentoring certain undergrad students. And for your information, I did not find even a single Pakistani undergrad in MIT, because there is no admission on donation in undergrad. Even if you are son of the president or prime minister, you cannot get admission. You can get admission in Harvard and Oxford on donation, but you cannot get into MIT. So not even a single undergrad student. There were two boys from Africa. I was mentoring them, and they were twin brothers. And they were sons of a clerk in an African country. And their GRE score, if you are familiar, most of you are because you are engineers, it was 1600 out of 1600 for one brother and 1590 out of 1600 for another brother. So you see, they were very poor, hailing from very poor background, but they had this remarkable capacity to work hard, and then like this dream to come over to MIT and create a future for themselves. Both of them were on 100% scholarship, and both of them were all set to become Nobel laureates some point down the line, because when I was studying in MIT, there were 70 Nobel laureates walking on the campus. So they say that everyone who is admitted into MIT is admitted with the potential to become Nobel laureate. It is how you structure your journey from there that decides that whether you will actually earn the Nobel Prize or not. So all of you, like you are cream of this nation. It is a privilege to be here. It is a privilege to be sitting in this hall, and it is a privilege to learn from the faculty of this high caliber. So my advice is that get hold of this opportunity. I basically hail from KP. And in my native village, when I was growing up, there was not even a primary school. There was not even electricity. My parents are illiterate. But my mother, she had a dream to educate her children. So from that very mediocre setting and very adverse environment, like in Pakhtun culture, education, especially in those far-flung areas, is not like the priority area. Or they want their kids to just grow up and just come over to Karachi or some other place and learn few skills or indulge into trade and business and start earning. So that is the ruling paradigm. But my mother was like, she was very impressed from Muhammad Ali Jinnah and all these leaders of the movement. So she like inculcated this idea that we should go for education and we should study ourselves. So I did not have the opportunity, and I am not a product of the structured system of education. Till BA, my education is private. I wanted to become a cricketer. I played grade 2 first class cricket as well. From BA onward, after graduating in 1996, I decided to go dedicated my life for education. And then I worked hard in LLB. In the third year of LLB, I qualified civil services exam. And after serving 4 or 5 years in the field, I felt that I am not a good professional in the field I am working. So I need to upgrade my education and skills. So I tried my level best, and I secured a scholarship in the University of Birmingham. And it is at that point of time that I came into contact with the leading practitioners of the industries, and that changed the whole scenario for myself. So the purpose of sharing this personal experience with you is that it is not the resources, it is not the environment, it is your own determination, your own visualization about the future that really matters. If you have this capacity of self-belief, and if you want to create the right kind of future for yourself, and if you are willing to do whatever it takes to create that future, I'm sure that future will be there. So let's take this opportunity and the presence of the learned Vice Chancellor, that from Pakistan Railway side, we will extend you every possible opportunity for studying, for inspecting, for doing your work. And you should make a vow that you will contribute in this dream of creating state-of-the-art rail transportation system for the country. And if we get a couple of committed scholars who would do research and who would help us create that future, it will be more than welcome. And I think with the kind of commitment and passion and energy that you guys have, and the kind of environment that we have right now, and the kind of prospects that the Pakistan has in this sector, I'm sure that with the right kind of collaboration, we will be able to succeed, and we will be able to change this scenario of hopelessness and bad safety profile that we are having right now. With these words, I express my gratitude to the learned Vice Chancellor and Dr. Shankar for providing me this opportunity and interact with the brilliant and creative minds over here. I thank you very much, sir, and I wish all the success for your endeavors in this institution. Thank you very much.
Thank you so much, Mr. Haniful. It was very informative and very motivating. I myself am very motivated. And when you talked about cricket, so it reminded me, we do have a captain here too. Professor Tanveer Hussain, he's the captain of cricket team here. And I myself am a basketball player and I'm a captain. Apart from that, quickly moving forward, we're going to be having launching ceremony of TAF tracker. So I will request to please Professor to come on the stage and start with the launching ceremony. I would request Ali to come here and tell something about the tracker.
Assalamu alaikum everyone. My name is Engineer Ali Akbar Shah. I am a senior researcher in National Center of Robotics and Automation Condition Monitoring Lab. We are here to launch a product named as TF Tracker, which is a track fault analyzer. It performs real-time analysis of railway track faults using initial sensors like accelerometer, gyroscope, as well as it can provide the location of the damaged track using GPS coordinates. It has an efficiency of over 93.7%, and it's been validated using sonar test ultrasonic flaw detector. We in NCRA welcome our railway officials for the launching of this product, which is a byproduct and a drive product of our recently been published research paper MOUs, which is having an impact factor of 9.95, and this product is also integrated on local servers as well as the cloud platform. Yes, sir. So the initial results that we have got from the validation of this is that we have diagnosed over 11 railway track faults on a diameter of 5-kilometer radius of the railway tracks in the Country Junction. And by validating those results using push trolley and the inspection team of Pakistan Railway, we have got the validation efficiency of over 100%.
Yes, that's gang people, and now we should go for automation. ML1 is coming, and this will extend actually 1 day up to 7 million. What price will be paid within next week? But for next week.
Thank you so much. Now I would request Professor Dr. Aslam Uqaili to present souvenir to Chief Guest, Mr. Hanif Gul, accompanying Dr. Bhavani Shankar and Dr. Tanveer. And I would request Professor Dr. Bhavani Shankar to kindly present Nazam as well. I would request Dr. Bhavani Shankar to kindly present souvenir adjunct engineer Amir Mohammad Daud Poto.
बहुत अरसे के बाद अब तो हम पीछे लगेंगे बुला लेंगे by aftermath. We lived together for about 5 years in any and I used to hear a lot about him from VC sir, but today we all together in one program. Thanks.
I would request Professor Dr. Bhavani Shankar to kindly present Nazam to Engineer Amir Mohammad Daud Poto. I would request Dr. Tanveer to kindly present souvenir to Engineer Kamran. I would request Dr.
Our alumni is a Mehran graduate, and he has helped us also local coordination.
I would request Dr. Jawad Daud Poto to kindly present a souvenir to Dr. Javed Daudpoto to present souvenir to Akhtar Malla. I would request Vice Chancellor, please, to give shield to Engineer Daudpoto. I would request Professor Dr. Mohammad Aslam Uqaili to kindly give shield to Professor Dr. Javed Daudpoto. Before ending this session today, I will leave you with this inspiring quote by John Wooden. Success is peace of mind, which is the direct result of self-satisfaction in knowing you made the effort to become the best of which you are. I will request Professor Dr. Mohammad Aslam Uqaili to kindly come here for the conclusion remark.
Bismillahirrahmanirrahim. Mr. Hanif Gul, the learned DS from Karachi Railway, and Amir Mohammad Daudpota Sahab, he is project director of Karachi Circular Railway. My hostel mate, my batch mate from NED Ministry, Dr. Bhavani Shankar Chaudhary Sahab, Dr. Tanveer, Dr. Javed, and other learned members, Dr. Mahar, dear participant, dear student, Assalamu alaikum. At the outset, I must acknowledge that we heard a wonderful speech from Hanif Gul Sahab, and he gave a lot of facts to you. And this is really, I'm very happy to hear such a wonderful information that what is the potential of railway. We all know that, and we all at some stage of time, I remember that when we were traveling from Beijing to Shanghai in this train, which is known as which actually having high-speed train, bullet train, yeah. And being an electrical engineer, I know that this train is not touching the track. It is slightly upper than the track because it has a lesser fraction so that it can achieve the higher speed. And we also come across a number of times that China is now very ambitious in stretching this rail to Europe. So who knows that people start traveling, and then the transient nations status. We all know right from very early time that Pakistan is blessed with wonderful ports. We have Karachi port, historically very famous port, but then we have also Qasem port and now the Gwadar port. So this gives us a lot of advantage to use the country as a transient facility. And this CPEC is basically, apart from this investment in the Pakistani infrastructure, the prime aim of the Chinese is that they want to export their product and import the product in their country via this Gwadar port, because it will reduce the time span, and especially the crops, the product which has a short shelf life, which require a lot of cold storage. There's a lot of potential of saving the energy because there's a 45 days ship route compared to 15 days ship route, or less than 15 days ship route to Middle East. Middle East is basically one of the area where you can consume a lot of your fruits and a lot of your vegetables and other products. So this reduces the time zone from like 45 days to, and through this red network, maybe 15, 20 days. So any one day is basically a lot of saving in terms of energy consumption in cold storage as well as in the transportation network. So with this in mind, obviously, then we need to actually establish a lot of investment in the railway network, because as very rightly told by Mr. Hanif Gul that it is one of the safest route after the aviation industry, and probably with high speed, as the data he has shared is equally good as compared to aviation even. So I think we have also the opportunity, but unfortunately, in the infrastructure and the railway network, our investment is very limited. And the major areas that while the whole world is moving towards automation and digitization, we are still using this gang man, as Amit told. For every 4 kilometers, there is a person. I think that's sometimes you think way behind the imagination that how the things are moving in our country. Yesterday, I was just coming from my hometown in the evening, and when I saw that people are still picking the woods from the same area, and my son was with me, and I was just sharing with him that I've been to Spain in the rural areas. When I was traveling from Madrid to Valencia, we come across number of those local areas, and but yet I haven't seen such thing there. It was organized, it was well managed. And then I also compare Thailand. Me and Bhavani Saab have actually attended one workshop in Chiang Mai and the other workshop in Chiang Rai. Unlike Bangkok or Phuket, which is more famous for the tourists, these are the rural side or countryside areas. And Chiang Mai was the place where it was famous for this cocaine, which is known as the Golden Triangle. And they have converted into, they have remodeled it. And there we also saw some structures, but when I compare those structures with our country, it looks that we are way behind. We are not comparing with Europe, where we are 100 years behind, but even with Thailand, which is agrarian country, and some 20, 30 years back, our economic per capita income was more than Thailand. But they have revolutionized. I mean, me and Bhavani were in Phuket, and somebody who's actually telling us that in the year 2017, 37 million tourists touched the area. And I was just being a data person, being an engineer, I just start calculating. If they spend only $500, which is not a big amount because having the facilities and the areas, and so this gives us 18.5 billion US dollar, the revenue generation from one city only. And we are looking to IMF for 1 or 2 billion every year, and we are literally pledging them that give us this money. Look at the potential available. And the potential, I tell you very honestly, we have immense potential. I always quote this, look at our resources in terms of fruit only, which is very common. I mean, people who are here, Dr. Tanveer, Javed, Mujawar, so many, and Hanif Gul Saab, Amir, they all travel outside world. Have you seen the finest apple in the world? They come from Pakistan. Finest grapes, fruit, finest grapes, cherry, you name the fruit, banana, you name the fruit, pomegranate, anything, mangoes, of course, the great season of mangoes. Yesterday, Dangadoka, Tanveer has given me Dangadoka. There's so many, even the rice. And amazingly, we were eating rice in some outside world, and they told us that it's Indian rice tilde. I say, hell to you. This is Basmati Pakistani rice or the Punjab from Punjab. How it is? Then we come to know that the rice is being exported to Dubai, that is marketed as an Indian product, it's being sold. This is how we are losing the revenue. This is how, because of our own attitudes, because of our own approaches. So I think we need to correct our approaches, and I really appreciate Hanif Gul Saab. People, it's not coincident that Germany has produced so many. He talked about MIT, where there was 17 Nobel laureate. I visited Gontagan, University of Gontagan. There were 36 Nobel laureates. 36 Nobel. Yeah. So it is amazing that people like us, they are actually become Nobel laureate at one of day because they work hard, because they have the attitude. And Hanif Saab, we in this university tried to bring this concept of ownership. What I realized by traveling different parts of the world, that some of the missing element in Pakistan is the act of belonging. We do not own our country. I mean, the people working in railway, they do not own the railway themselves. I mean, they never say my railway. They say our railway. So here in this university, we change this idea of using the word my. Unfortunately, in this country, we only use word my for our homes. So it is my homes is beautiful, wonderful, but my street is not mine. So that's a disaster. Amir lived in Hyderabad. Amir lived in probably close to civil line area. And he knows that the houses are wonderful. Even in Qasimabad, Latifabad, you find excellent houses. But when you come out the house, you see the streets, they are disaster because they are never owned. And this is what I actually ask my students, my faculty, my employees, and everybody, that let's call this university, my auditorium, my classroom, my teachers, because my give you an ownership. And I'm happy to share that if somebody asks me, because this is my last tenure, and I'm completing this second tenure in January. I already been selected for Daud. Maybe I have been leaving tomorrow as a vice chancellor there. I don't know. But what I gave this university is this culture of this is my only achievement, which I'm proud. All these things which are happening this in the last 8 years, because we are the strong believer, as Amir said, that we are a strong believer of helix, triple helix, which is UIG, University, Industry, and Government. And we also added one more triangle, one more corner in it. We call it quadro helix, where this triple helix will benefit the community, because that is the ultimate aim. Because triple helix will not be complete without involving the communities where the service is provided. So we call it quadro helix, where we want that triple helix to be benefiting the community. The research and everything, ultimately, if it is not benefiting the community, having wonderful impact factor, having lots of papers on our name, yes, we got benefit by getting promotions and getting grade 22, and that is our feeling. But then if it is not benefiting to the community, then there's no use of it. So I'm happy to see that now the things are coming. The universities in the 20 years back, they were only colleges where there are only one element of knowledge is being taking place, which is knowledge transfer, where we are providing degree holders. But now I'm happy to share that knowledge creation, which is the second domain, is taking place. Then after creation, knowledge application, where the knowledge is being applied, that is also being taking place. And finally, knowledge integration, where the knowledge benefit the community. So Mehran is now, alhamdulillah, in the fourth stage. These small devices, they will basically help communities. They will reduce the labor work. They will improve the cost incurred on this particular phenomena. And then if somehow they reduce, because when you are having a lot of, in the recent past, there are a lot of accidents in the railway network. And it is not the fault, because we are still using those traditional man-made control system, monitoring system. We need to really move forward to those systems. This is the only solution. So thank you very much for your presence here. And I'm also thankful to our friend Nisar, who was our batchmate. He is now CEO of Pakistan Railway, and he was also here some time back, and we expect him sometime again. And we are also thankful to Pakistan Railway. They have provided this small track, which actually gives these researchers an opportunity to do some activities on that and give some real-time solution for the railway. Thank you very much for listening. Thank you. And I appreciate Bhavani Saab, Tanveer, and everybody for this.
थैंक यू सो मच सर। मैं बहुत शुक्रगुजार हूँ आप सब की, सारे गेस्ट की, स्टूडेंट्स की। आप लोग यहाँ पे आए, स्पेशली जो हमारे गेस्ट है वो यहाँ पे आए अपने इतने बिजी शेड्यूल में से टाइम निकाल के हमें वक्त देने के लिए, इस वर्कशॉप में शामिल होने के लिए। सो अपनी टीम की तरफ से मैं आप सबकी बहुत ज़्यादा शुक्रगुजार हूँ, स्पेशली वाइस चांसलर साहब, जिनकी मैं आज तक उनका नाम नहीं ले पाती क्योंकि कभी नाम लिया नहीं, हमेशा वाइस चांसलर साहब जी कहा है। सो आई एम वेरी थैंकफुल टू हिम, क्योंकि मैंने पहले भी कहा था कि माई यूनिवर्सिटी का कॉन्सेप्ट सर ही लाए थे। और इसके अलावा एक बात कहना चाहूँगी, सॉरी मैं आपका टाइम ले रही हूँ, कि जब हमारे पास बेहतरीन लीडर होते हैं उसके बाद ही फॉलोअर्स जो भी हमारे लीडर की क्वालिटीज़ होती हैं उसे फॉलो करते हैं। एंड अल्हम्दुलिल्लाह जो हमारे वाइस चांसलर हैं वो काफ़ी कंपोज्ड हैं। ये चीज़ मैंने ऑब्जर्व किया बीइंग अ थर्ड पार्टी ऑब्जर्वर, कि वो जब भी बोलते हैं वो लफ्ज़ों को तोलते हैं, उन्हें पता होता है कि कब, कहाँ, कितनी और कैसे बात करनी है। और काफ़ी कम लोग होते हैं ऐसे जो एजुकेटेड भी हों, लेकिन कभी कभार anyways. Thank you so much for being here. I really appreciate it. And now it's time for tea break. I would request you guys to move towards the canteen.